Kubernetes Workflow. Kubernetes is an open-source container orchestration platform that helps automating the deployment, scaling, and management of containerized applications. In this part of the course, we will explore the workflow of Kubernetes, which includes the various stages and processes involved in using Kubernetes to run applications. Before starting the Kubernetes workflow, it is essential to have a clear understanding of the application that needs to be deployed. This involves defining the requirements, dependencies, and resources needed by the application. It is crucial to consider factors such as container images, environment variables, storage, networking, and any other specific configuration settings required. The next step in the workflow is to create a Kubernetes cluster, which is a set of physical or virtual machines that will run the Kubernetes control plane and worker nodes. There are various options available to create a cluster, such as using managed Kubernetes services from cloud providers like Amazon EKS, Google Kubernetes Engine, or Azure Kubernetes Service. Alternatively, you can use tools like Kops, Kubispray, or Kubeatom to create a cluster on your own infrastructure. Once the cluster is set up, the next step is to deploy the required Kubernetes objects, such as pods, services, deployments, and namespaces. These objects are defined in YAML manifests and can be created using the kubectl apply command. Pods are the smallest deployable units in Kubernetes and encapsulate one or more containers. They represent a single instance of an application. Services enable communication between pods and provide a stable network endpoint for accessing the application. Deployments manage the lifecycle of pods, ensuring the desired number of replicas are running and handling rolling updates or rollbacks. Namespaces provide a way to logically isolate and partition resources within a cluster. Once the application is deployed, it is crucial to monitor its performance, health, and resource utilization. Kubernetes provides various monitoring and logging tools that can be integrated with the cluster to track metrics and identify potential issues. Some popular monitoring tools include Prometheus, Grafana, and Elasticsearch. One of the significant advantages of using Kubernetes is its ability to scale applications based on demand. Kubernetes supports both manual scaling and autoscaling. Manual scaling involves manually adjusting the number of pod replicas using the kubectl scale command. Autoscaling, on the other hand, automatically adjusts the number of replicas based on predefined metrics such as CPU or memory utilization. Kubernetes makes it easy to update applications without disrupting the running services. Rolling updates allow you to update pods one by one, ensuring continuous availability. If any issues are identified during the update, Kubernetes allows you to perform rollbacks to the previous version of the application. To ensure the resilience and availability of applications, it is crucial to have a backup and disaster recovery plan in place. Kubernetes provides tools like Velero, formerly HeptioArch, that enable backup and restore operations for both persistent volumes and cluster resources. Integrating Kubernetes into a CI/CD pipeline enables a streamlined workflow for application development and deployment. CI/CD tools like Jenkins, GitLab CI, or Argo CD can be used to automate build, test, and deployment processes, ensuring a smooth delivery of applications to Kubernetes clusters. In this part of the course, we explored the workflow of Kubernetes, covering various stages and processes involved in running applications on Kubernetes. We started by defining the application, creating the cluster, deploying Kubernetes objects, monitoring the application, scaling, performing updates and rollbacks, backup and disaster recovery, and integrating Kubernetes into a CI/CD pipeline. Based on these steps, you can effectively utilize Kubernetes to manage and orchestrate containerized applications.